of all, I would like to thank you for accepting this invitation to deliver a talk as part of this Mosaic Lab Invited Talk series. Today's talk is about something which is very promising, 6G, although we are still struggling to enjoy 5G. But, you know, in the research community, we have already started, you know, talking about 6G and how it should look like. Today's concept is really interesting, and I think you have captured that very nicely in the title of your talk, Ultimate Customizability. I hope I'm pronouncing it right, which is driven by democratization. And this is really interesting. I mean, it's a very interesting concept which we would like to be introduced to. Today's speaker is a very old friend of mine. We've been collaborating since, I think, seven years, and we had a very successful European project, which is 5G Pagoda. I think Professor Nakao will speak about it very briefly. But let me introduce Professor Nakao, or Nakao Sensei, as we say in Japanese. So Nakao Sensei received his bachelor degree in physics in 1991, and then master degree in 1994 in information engineering. That's just 2 years before even I finished my high school. So he got it from the University of Tokyo, which is one of the top universities in Japan. It's actually one of the top imperial universities in Japan. He then worked for IBM Japan and then IBM Texas from 1994 till 2005. The thing which is really interesting is while working for IBM USA, a very demanding job, he was also working towards his master's degree and PhD in computer science, and he got it from one of the top universities in the US, Princeton University. You're really in front of a very hard-working person since, I think, childhood. He's currently a full professor at the University of Tokyo. He is also serving as Vice Dean of the University of Tokyo's Interfaculty Initiative Information Studies. That was since 2019 till now. He's been appointed as an advisor and currently as special advisor to the president of the University of Tokyo. This is a very actually prestigious appointment. He served as a chairperson of the Network Architecture Committee of the 5G Mobile Network Promotion Forum in 2014. That's actually the one that defined, let's say, 5G architecture, you know, from the Japanese perspective. Currently, he's serving as a chairperson of the International Committee of Beyond 5G Promotion Consortium of Japan in 2020, which is launched just, I think, maybe a few weeks ago or maybe last month, I think. And I think Nakao Sensei will be introducing that. So Nakao Sensei, the floor is yours.
Okay, thank you very much for a great introduction, Tariq. I'm Aki Nakao from the University of Tokyo. As Tariq said, we are, you know, good friends, and we did lots of projects together. And we like, you know, when we work together, we work like, you know, very hard. So today I would like to introduce our research work, what's happening in the University of Tokyo, especially in my lab. So I don't have to introduce myself because Tariq already did a great introduction. But newly, you know, we decided to work on Beyond 5G, which is 6G, similar to the one already, that has started in, I think, 2018, and 6G flagship project in Finland. So we are following all the white papers and all the the workshops and stuff. And we would like to do similar activity in this Beyond 5G Promotion Consortium. I'm the chairman of international committee of there, and we did a lot of 5G and Beyond 5G related committees, and I'm playing this chairman roles in several of them. So let me start my presentation by SDGs. Yesterday, Professor Matti Latvo-Eho, the director of 6G flagship project, did a great presentation at one of the our international committee, the Beyond 5G Promotion Consortium. And we learned that we share the same view. We are targeting at this, sustainable development goals when we develop the 6G technology. So this is actually one of the slogans that the UTokyo is promoting up front. So if you go to the top web page of UTokyo, you're going to see that SDG-oriented projects. And we listed lots of projects, research projects, grouped into categories, which are based on these 17 SDGs. And one of them, listed project is this one, the 5G Pagoda project. We filed over 100 contributions to 3GPP and also ITUT, and Tariq and I were co-PI of this project for the duration of 3 years from 2016 and 2019. So we did a network slicing, but per application network slicing over the Japan and European testbed, we constructed the testbed to verify and evaluate this concept by actually developing this testbed. That was a very nice project, and we are all proud of this project. So what's happening in Japan? 5G frequency is already allocated. We have 4 MNOs now. NTT Docomo, KDDI, and SoftBank are well-known 3 MNOs, but Rakuten Mobile joined this competition, and we allocated for the frequency bands for 4 MNOs. And Rakuten Mobile is an interesting company. So they are using softwareized infrastructure. So, and they are pushing very hard and deploying their base stations now. And so this is the frequency chart of which frequency band is allocated to which MNO companies. We use 3.7 gigahertz, 4.5 gigahertz, which is called a sub-6, and a 28 gigahertz millimeter wave band. So if you look at this white part, white space, we have some bands left. Japanese government, the Ministry of Internal Affairs and Communication, decided to allocate this band, the white space, for local 5G, the private 5G in Japan. So, so they first thought that, maybe frequency interference is easier to resolve if we use a millimeter wave band. So they first allocated 100 megahertz from 28.2 to 28.3 band for, millimeter wave band for local 5G. And just a few months ago, December, last year, so they allocated sub-6 band, 4.6 to 4.9 gigahertz. And what is interesting is that from 4.8 to 4.9, we have open area, of course with the restrictions, but open area local 5G, the frequency band is available. So you can set up your own base station. Even university professors can get a license to operate their own base station of local 5G. So what is democratization of telecommunication? I put that title, put democratization in my talk title. But democratization, when it is used for technology, this is the action of making something is like some technology accessible to everyone. So, and when it applied to when it is applied to telecommunication, this means that to make radio frequency license available to everyone, not just the telecom operators, but such as like a local 5G is allocated for the regular people, regular industry people, the university professors, even students. Maybe they can get a license to use this band. So my belief is that the divergence and the inclusiveness are key drivers for innovations for next generation networking. So the reason why I think that democratization is the key to innovation is that the following. So we are a very small network research community, but when the private frequency band is available for regular people and everything gets open source, and if we enable regional customization using this frequency band and also open source software, so then we can enhance the community to various different type of areas like computation, AI, quantum physics, and brain scientists. So these people can join the force and make a lot of customization for using this democratized telecommunication. So basically, we can involve other field researchers into a network research community. And as you can see in AI and machine learning field, the same thing is happening right now. So we can open source everything and include different people from different areas and make a lot of innovations using this technique. So in my opinion, the 6G will be coming from democratized communication technologies. So I always use this chart to explain this. 6G will be initiated bottom up from a local 6G and a private 6G. So the regular evolution path is from 5G to 6G. So, like we did from 4G to 5G, telecom operators, network equipment vendors get together and try to standardize the 6G. So this is a regular evolution path. But because we have a private networks and the local 5G has emerged, so this local 5G is really use case driven because it's in the hand of regular people. So they have lots of local problem challenges, and they customize the communication tailored to their need. So the various innovations are driven by customizations. And these customization can lead to innovations. So I call the local 5G is going to be evolve into local 6G. So then we extract the common features and define a 6G. So we have another avenue to evolve into 6G. So what kind of customizations are considered here? So we think that the low-cost mobile infrastructure. So I can introduce the local 5G in the box in a minute, and also uplink optimization, low power operation, custom security, etc. So there are lots of interesting customization driven by the use cases. So we face the challenges in 5G deployment. So we worked with lots of MNO company and did a few trials before 5G got deployed. And there are mainly three challenges identified. So the first one is timely deployment of 5G. So when is 5G coming to our region anytime soon? So usually, deployment, even now, so the 5G is not deployed very quickly. And the second one is mismatch between supply and demand of 5G. So, people who like to use 5G would always say, does any telco deploy 5G in the rural area like, where I'm living? So, especially in the rural area, the MNOs make a have a hard time making a business case there because there are not many people using 5G anytime soon. So it's, it causes a slow deployment of 5G there. And the third one is for us, for researchers, advanced research integration in 5G. So does any telco deploy our research results? Talik and I did a great work in application-based slicing, but that's, the question is, does any telco deploy our research results anytime soon? So, but we think that the democratization, such as local 5G approach, is a key to solve all of these. So we decided to deploy our own democratized 5G in the area to attack and resolve these challenges. So this is how we, how to make innovations from local 5G to local 6G. So let me explain this, the example project that we did in the southern part of Japan, 5G application to local fishery business. So oyster farming. So we love oysters. So this oyster is, farming is very famous in this part of Japan. It's Itashima City, Hiroshima Prefecture, Japan. If you have visited Japan, so Hiroshima, is a very nice place. And if you go to this, very big island, the Y-shaped island, which is called Itashima Island, and this inner sea has a lot of oyster rafts floating on the surface of the sea, and this area is top in ranking in oyster catches in Japan. And so we decided to apply this 5G technologies to save the labor work of a fisherman, because they have to go to the oyster raft here and check the growth of the oysters every day, and nothing bad, is happening. They have to make sure. So, but you have to go there every day and do that. And there are a number of hundreds of oyster rafts there. So it's very hard to do that. So we introduced underwater drone to operate this drone from the seashore by using the 5G. So this is a joint work with Docomo, and we use the 28 gigahertz band to control the underwater drone. And at the same time, we use large bandwidth for live video streaming so that we can watch the healthy growth of oysters remotely. So 28 gigahertz millimeter wave band over 100 to 150 meter distance between the board and seashore. So we can operate underwater drone by the ultra low latency, and also we can deliver the real-time video streaming. So this was done in 2019 with NTT Docomo. At that time, a drone is not very good in shape. The picture is okay, but it's harder to control underwater drone. But so this caught people's attention very much because this type of video, fishermen especially, it's really the first time for them to see undersea by 5G, using 5G and underwater drone. So we have to use ultra low latency because if you want to control the underwater drone, the delay is a very stringent requirement. If it has delay, so then it's not good for controlling drone. So we did this in 2019, but then, so at that time we used the public 5G, experimental public 5G there. But it doesn't make sense for NTT Docomo to deploy the base stations there. So we, as I told you in the previous slide, we face the challenge number one, right? So there is, so the 5G deployment is not as fast as the one we expect. So we decided to deploy local 5G there. And this time we used sub-6 standalone, enabling UMBB and also URLLC. The same idea, but different setup, different frequency band, and also we use better underwater drone. And this time we included NEC and the layers consulting. I'm sorry about the Japanese here, but if you look at this picture, we do very similar things as before, but we're using local 5G here. In fact, we use the public 5G and local 5G at the same time, because we like to see that when we deploy local 5G and at the same time Docomo deploys a public 5G, we don't like to see the interference there. So we have to make sure that both frequency bands are not interfered when we use them at the same time. So antenna site that we chose is this one, the old building, and we set up antenna site there, and we did three kinds of experiments there. The field experiment of signal reception with local 5G, and also we did wider scale use case scenarios, and we deploy the bunch of underwater drones there to and also control within the range of the frequency. And also a coexistence examination. The local 5G that we use is 4.7 to 4.8. Public 5G is 4.5 to 4.6. So we operate at the same time, and we make sure that the both bands are not getting in the way of each other. So actual setup is like this. And I can quickly show, quickly click the slides to show the setup. And, we set a boat and try to measure the wave propagation. So from the antennas at the lodge, so you see that about 200 meters away in this picture, but we explore this the space and up to like 600 meters away from the single antenna site. And so we set a board and we spectrum analyzer. We use the spectrum analyzer together with the UE and measure the strength of the signal. So you see that lots of oysters wrapped there, and we set a boat and going through all these areas, and then we measure the frequency band. So this yellow marker is that you can, signal reception is fine there, and we can transmit the video streaming data to the antenna site. Antenna site is right here. We set a boat and going over and measure the strength of the signal. So I'm not going into the detail of the setup, but we can connect like 3 underwater drones, and we operate local 5G signals there. And from the coast, we can control the underwater drone, and we can see the real-time video streaming. So this is the actual picture of so. By the way, we are doing this experiment right now in Hiroshima. So right at this point. And this week, I'm gonna fly to Hiroshima area there. And we have to show this experiment to the ministry people there who we are presenting. So in this video, so I'm operating 2 drones, and one drone is watching the other drone here. And you see that the oysters are hanging from the rafts there, and it's trying to capture the image of the oysters there. But as you can see that the operation of underwater drone is very stable. And if you look at the, okay, let's look at the video that the other drone is taking. So I hope that Zoom is delivering a fine video to you, but you can capture this very fine picture of oysters hang from the oysters farming rafts. And also there are floating, I don't know what it is, but some, plankton or something is floating around, and you can capture all those. And the color of the oyster shell, I didn't see that, before. It was very fascinating, and fisherman is also very surprised to see this hang oysters from the raft. So you can do these things using 5G, URLLC, and EMDD. This is a great example for digital transformation of a fishery business. And so everyone who watched this video loved this use case. There's another video, and you can skip that if you're interested. I can show you more. But another thing is that at the bottom of the inner sea, so there are lots of garbages sunk from the oysters raft. Basically, what we see here is not very pretty, but the shells of the oysters are accumulated at the bottom of the sea. So as soon as Hiroshima Prefecture officials saw this video, so they decided to clean up the bottom of the sea. So if you look at this video, so you are urged to clean up the bottom of the sea. So which was unexpectedly a good thing, but this is one of the outcome of our project. Okay, so let's talk about a technical thing. So the local 5G in the box is a software 5G SA and NSA setup that we developed. So we take the COTS PC, and for NSA, we use the band 41 and band N79. And SA setting, we use band N79. So we put an SDR card and a COTS PC, and we can do a very flexible setup. We can choose between NSA and SAS at the same time. So as I said before, so the millimeter wave NSA was introduced in December 2019 for a local 5G setup. But recently, in December last year, South 6 standalone got ready, so we can get a license of that. So in Itajima project of oyster farming, so we use a South 6 SA already using a software based the base station. So we worked on the RF part, and we actually bought a license of the software. And we modify a little bit, customize a little bit, so that we can tailor this space station for our own use case. So we take a software G-Node-D and a software 5G core and put it into the PC. Well, so this PC is a giant PC, but inside it's a regular Intel cards PC, and people use that for gaming usually. Because it's powerful, but it doesn't have to be a very big one. You can choose the small one, but for the ventilation, we use the big one. And we worked on, so this part was the hardest part. We worked on RF, and we collected the amplifier, low noise amplifier and a power amp, and also, bandpass filter, the narrow band pass filter also. And we combined them together, and we constructed this system. So, and we customized this this base station so that we can get the very large uplink speed. So we set up this downlink optimization. So then we can achieve a download speed of over 500 megabps. But if you look at the upload, so it's like a regular public 5G setup. We can achieve only a few tens of megabps. But we optimize for uplink, so then we can achieve upload of 200 megabps. Download 250 and upload 200. So this type of optimization is very useful for underwater drone use case, because we have to upload high definition video, sometimes 4K and even 8K video can be uploaded using this bandwidth. And we can operate multiple underwater drones there. So the objective here are twofold. So we would like to realize low cost base station. And also we have to customize. We have to achieve customization of uplink optimization using the software. So by just pressing a button, we can switch between a downlink and uplink optimization because it's very flexible setup. And we show that to CEO of NTT East, and this is our president of the school, and this is the local governor. So they all loved our base station and setup. So we did this experiment at the university, and then we brought this to a local region, and we actually operated this base station there. Okay. So another way to reduce cost we are looking at is the following. Maybe I'm running out of time, so we can quickly show that the infrastructure sharing idea. So this is the joint project with the Rakuten and NEC. So usually MNO has their own setup of 5GC and G0B. But if we can cloudify the 5GC, which is actually happening right now, so then we can prepare only local 5G CUD and RU and connect them if it is 3GPP compliant interface. So then we can connect them. So this way we can use 5GC as a cloud by MNO. We prepare only local 5G G0B there and connect them so that we can reduce the cost. So if you push this idea further, and if it is ORAN compliant, so then we can prepare only RU for local 5G and cloudify CUDU and 5GC. And while MNO is using their own RU connected their CU and DU, so the local 5G operator can just prepare the RU and connect to the CU and DU. So this is the power of open interface, and we are trying to achieve this. And also, if you push this even farther, so then local 5G operator may not prepare anything. So the 5G CU, DU, and RU are all shared, all cloudified. And so this RU can support MNOs and the local 5G frequency band. And by time slotting, so we can allocate. So it's just like the regular cloud system. We can allocate the bandwidth and computation by maybe time-wise. So then we can reduce even further cost. So requirements, all of the interface must be strictly ORAN compliant. So we are, adding our own G0B, and also Rakuten and NEC are working. Everything is ORAN compliant. Everything is interoperated. So this is a great project, and this is only a 3-year project, but we started last year. Okay. So what democratization means to researchers like us. So we have lots of interesting ideas, but we can use democratized telecommunication test as a test bed for new technologies. So one of the things that we are trying to do is per application network slicing. So this idea was developed in our joint project with Tariq, the 5G Pagoda. But I can give you example of per application slicing. So if you remember the underwater drone video streaming and underwater drone control, underwater drone sensors. So we didn't show the sensor part, but this drone has a sensor, all kinds of sensors there. So if we send them all, this is just one UE, but if you send them all over to the cloud using the shared link, so then 3GPP already standardized the UE-based slicing, but we have to push that idea further to the application-based. So if we can make a slice per application, so in this use case, we can isolate traffic of underwater drone video streaming and underwater drone control and sensors. So all of them may require different type of communication features. So this makes sense to do even in this use case. It makes sense to do application-based network slicing. So if you want to do this type of application-based network slicing, so then you have to develop your own hardware. But if you approach MNO, it takes a long time to convince them to pick up our technology. So instead of doing that, we decided to do that in local 5G setup. So this is the result of per application slicing. Not just the total number of traffic, you can classify the traffic per application. You can think of this each color is a different application, traffic from the different application. So, and you can do a fine-grained QoS control per application. You can even stop the application traffic. You can do a width cap and all that. Lots of opportunities of interesting application use case there. So due to the time constraint, let me quickly show COVID-19 countermeasure of application. So we try to use a local 5G to do lively 3D VR-based education. So this is actually developed by my student. And the idea is very simple, to capture social activities of human into 3D model, like point cloud, and then compress the 3D model and reconstruct the model remotely using local 5G, so that we can give an illusion that the two remote parties physically coexisted in the same place. So basically, we are enhancing the 2D remote education into lively the VR-based education. So let's look at the this video. So in order to capture the 3D image, we use 3D scanning with a depth camera by Intel. So the data generated by this depth camera is very large, but we can compress that and doing a 3D model reconstruction with the HoloLens, so that we can get a hologram image. And we can actually transfer this 3D image over a local 5G. So if you use more cameras, you can get a more complete pictures. So we'd like to do this. We like to use this type of application to enable lively 3D VR-based education under COVID-19 situation. Okay. So for the next decade, so as I said, I'm arguing that, I'm positing that this 6G is coming from the local 5G to local 6G and then to 6G. But in June 2020, the strategic proposal for 6G R&D has been summarized by the Ministry of Internal Affairs and Communication. And so there are a lot of directions similar to white papers in other projects, other countries. These blue boxes is enhancing the features of 5G. So even farther, like 10 times faster, 1/10 of latency in 5G, 10 times more UEs than 5G. And these 4 boxes, the targets for different type of KPI than 5G. The auto low power consumption, auto security and resiliency, autonomy and scalability. I'm very much interested in autonomy and scalability, and we started several projects for these directions, autonomy and scalability. Autonomy is basically including machine learning and AI into beyond 5G, and scalability means that we are extending the coverage of telecommunication, hubs and satellite communication. So for autonomy, we use ITU AI ML in a 5G challenge. So this is the contest. We invite all students from all over the world and do the contest of applying AI and 5G. One of the students of mine won the 3rd prize in global contest. So just quickly, I don't have time to cover all these. KDDI and UTOKYO are trying to integrate a super intelligent network engine into beyond 5G. So this is one of the projects. And also we are using the high throughput satellite combined with 5G. And also we are adding some edge computing and cache and function distribution combined with the satellite and 5G. And also for local 5G, we are connecting local 5G setup with the satellite communication. So in Japan, we have Sky Perfect TV, that's the satellite TV company, and we are collaborating with them. And JRC is providing the modem of the satellite. And so this is another exciting project. So as a recap, another innovation path is possible right now. So we are trying to push this local 5G to local 6G. So we believe that both ways, standard evolution and this another innovation path. So these are the 2 important innovation paths that we should push right now. Okay, so this is my last slide. I already covered everything. Democratization will open the door to the innovations towards beyond 5G and 6G. So we believe that pushing private 5G to private 6G is one of the ways to promote this 6G research. And if you agree, we'd like to collaborate with lots of European partners, and we'd love to see this joint project in the future. Thank you very much for your attention. This is the end of my talk. I'm happy to take any questions.